Unit 1. Force and Motion. Lesson 3. Physical quantities, scalars, and vectors. Physical quantities. What's meant by physical quantity? It is any quantity that can be determined and has a unit of measurement in our life. For examples, mass is measured in kilogram or gram. Length is measured in meter or kilometer. Time is measured in second or hour. Speed is measured in meter per second or kilometer per hour. Force is measured in Newton. Energy is measured in joule. Temperature is measured in degrees Celsius or degree Fahrenheit. Velocity, it has the same unit as speed, meter per second or kilometer per hour. Pressure, its unit is Pascal or Newton per meter squared. Displacement, it has the same unit as distance, meter or kilometer. Acceleration, its measuring unit is meter per second squared or kilometer per hour squared. All of these quantities are called physical quantities because they can be measured and they have a unit of measurement. Let's compare between a scalar physical quantity and vector physical quantity. What's meant by a scalar physical quantity? It is a physical quantity that has magnitude only and has no direction. Magnitude means numerical value and unit. For example, to measure the distance or the length of your disk, the length of your disk is about 1.5 meter. 1.5 meter is called magnitude. We don't need to know the direction of the disk to define its length. We need to find its magnitude only. So length is a scalar physical quantity. While vector, it is the physical quantity that has magnitude and direction. For scalar physical quantity to be defined, we need to know its magnitude only by giving its numerical value, number, and its measuring unit, its unit. But for vector physical quantity, it is necessary to know its magnitude by giving its numerical value and its measuring unit, and also its direction. Examples for scalar physical quantities such as mass, which is measured in kilogram, length in meter, speed, meter per second, time in second, energy in joule, temperature in degrees Celsius or degree Fahrenheit. All these physical quantities are called scalar physical quantities because we need only to know their magnitudes to be defined. Examples for vector physical quantities: acceleration, meter per second squared. Force and weight, they have the same unit, which is Newton. Velocity, which is measured in meter per second. Displacement, which is measured in meter. All these quantities are vector physical quantities because to be defined, we must know their magnitudes and direction as well. Let's compare between distance as an example for scalar physical quantity and displacement as an example for vector physical quantity. What's meant by distance? Distance, it is the actual length of the path that a moving body covers from the starting point to the ending point. While displacement means it is the shortest straight line between the starting point and the ending point. To determine distance, we have to know its magnitude only, but to determine displacement, we have to know its magnitude and its direction. Distance is scalar quantity, while displacement is a vector quantity. Distance is measured in meter or kilometer, and displacement has the same units, which are meter and kilometer. We have an example here. We have an object which moved to east a distance of 50 meter, then return it back to its original position, 50 meter. So this object covered 100 meter for distance, but its displacement in this case is equal to 0, because this point is its starting point and it is the same as its ending point. So its displacement is equal to 0 because the ending point is the same as the starting point. So the distance between them is 0. The two equal displacement have the same magnitude and the same direction. If we have a car, this car moved from point A to B, a distance of 100 meter, then we have the same car return it back from B as a starting point to A and covered 100 meters. Are the two displacements equal to each other? The answer is no. The first displacement is from A to B in AB direction, while the second displacement is from B to A, is in the direction of VA. For two displacements to be equal, they must have the same magnitude and the same direction as well. Displacement may be equal 0. This is done when the object moves where the starting point is the same as its ending point. If we have a car, this car moved from A to B, a distance of 100 meter, then return it back to its starting position. In this case, its total distance is 200, while its displacement is 0, because its starting point is its ending point. In this case, displacement equals 0.